Hey everybody, this is Larry, this is Miko Q4 of the weekly contest 322, divide nodes into the maximum number of groups. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So I'm going to go over my thought process in a post-mortem kind of way, or retrospective kind of way first. And the first thing I would say to notice is that n, or in this case v, is 500. And what that means is that you can do v square e things, maybe. So you have to, so that's just one of the things that maybe you can think about, doing as well. Because for me, honestly, I spent a lot of time just thinking about doing it in linear time, to be honest. And that really wasted a lot of time for me. And what cleared up for me was I was like, oh, wait, I don't need to be at linear. And I was thinking of some version of like that first search with respect to like Tarjans and something like this. Like that kind of like articulation point E type thing, going things that way. But yeah, and then after a while, I just kind of saw it in a different way and was able to solve it, I guess, which is kind of nice. But we will go over it, don't worry. The first thing to notice is that the graph has to be bipartite, right? Meaning that if it's not bipartite, or two-colorable, if you will, in another term, if that's not the case, then you cannot have these groups, because then you have a 3 cycle or K3 or whatever, right? And that's just, you can't really have that's the definition of this problem. So I kind of wasn't figuring it out, so I sort of did this, and this could be done in linear time. This is just very basic colorable stuff, so definitely I'm not going to go over it in this particular problem, but if you I probably have other videos for this. So basically that's what I'm trying to do here. If this part interests you, then take a look at that part. The harder part for me is, like I said, it's about the other half, and the half that I was trying to think about is how to kind of how to represent this, how to visualize this in a good way. And the way that I would say to do this is, like I said, pointing out that n is equal to 500. And because n is equal to 500 or v is equal to 500, then you can kind of just dangle almost like like basically what I'm trying to do is create a shortest path spanning tree, right? And meaning that at each node, meaning, okay, in this case, for example, maybe I first start, by drawing a node at node 1, and then now, so group 1 is going to be the number 1 in this case. Hope you're looking at it with me. I'm not drawing it this time, but. And then in group 2, it'll be 5, 2, and 4, because they're all close to the number 1. And by definition, and the bipartite check that we've done, this means that they're on the same level. And then the other nodes that we haven't seen before, they're in the next group, right? Because that's by definition as well. So in that sense, you can partition every number according to this. However, that may not be optimal, because, for example, in this case, if we pick 1 as the root, then you're going to get 3 as the number of groups, and that's the maximum groups that you're going to get. However, you want to do it from 5, and that's where the v square and v is equal to 500 comes into play, because you can do that. So basically what I did is that I got a score for every number, and the score in this case is just the depth of the I could probably have done this in one function actually, but basically the depth of all the distances, right? Like basically if I is the root, then what is the depth, or like what is the depth of that shortest path spanning tree, or the farthest node from from I, right, from this node. And then after that, so the tricky thing about this problem, and I didn't do it because I earlier in the exploration, I noticed that it was disconnected. So I knew that I have to figure out the forest, meaning multiple components or trees, and then combine them, right? Meaning if you have one thing that has a maximum group 4 and another thing that maximum group 3, then you combine them into maximum group 7. So So I kind of wrote this in a weird way where basically, and you can maybe yeah, maybe you could do it with what you call it, Union Fine or something like this as well. But the way that I did it is that I got the score for basically this is the depth if the shortest path spanning tree is rooted at I, and then now this is a basic forest thing, right? Meaning that, okay, so for this forest at I, we look at every node that's connected to I, and obviously the entire tree that is, or graph that's in that, in all the connections, and then basically get the maximum score out inside that. So then you have the score, and then you look at the max of whatever they return and return max recursively. And then in that way, yeah, we do a depth first search. And then we add that to the component. So each component we add to the total contribution. And that's pretty much it, really. So yeah, let's go with complexity really quick. So this is linear, this is bipartite. We look at each node one, so that's linear. This is just putting the edges. And by linear, I mean v plus y, where y can be as bad as v squared, but not as quite, depending on how you do it, I suppose. And this part is just regular breadth first search. So this is v plus e. But v plus e for that component, so it's not a full e, or it could be, I guess. But yeah, and in this case, this is v times v plus e, so v squared plus v times e, and then here this is just linear time, which is v plus e. So in total, time is going to be O of v times v plus e, or dominated by, and then space is just O of, I think v actually. I don't think. Well, I mean, I guess y, because we transform it into an adjacency list. But yeah, so that's pretty much all I have for this one. Let me know what you think. It's kind of really tricky, but once you kind of realize that, I don't know, at least for me, once I realized that I could do an v square, and then now if we have the shortest path spanning tree, this is basically the definition of the levels that are distances away, right? So yeah, I definitely tried another, like I said, I tried other things with like Targent, and I was trying too hard to be linear, and that kind of ended up costing me a lot of time as a result. But that's all I have for this one. So let me know what you think. So stay good. Oh no, well, I mean, sure, stay good as well. But you could watch me solve it live during the contest now. Dumbass, I'm a dummy. This is gonna be tragic. So 2000. Hard on myself today. Shouldn't have done it. Didn't feel like doing it today, but I had some pain. No one's gotten it yet, so that's gonna probably be a hard one. Okay. You have edges. M groups such that each node, okay, every pair of the node. Say what? A and B, if A sub I belongs to group index X, and is this bipartite? And it's 500, so something funky. This is not going to be great. It is bipartite, but can we have? Oh, but it's 4 groups. I say you have to do the number of groups. If it's not bipartite, then it's -1. If it's bipartite, then you have an answer no matter what, which is either 1 or 2, depending on how elements. How do you stretch it out? getting it now though. About like 10 minutes. Forces this to be. What forces this to be group 3? Or like. Group 1, so if I have a group 1, everything that touches is group 2. Right? Everything that touches is group. So the back edges the back edges. Can I find it? I think I need more cases. This one is not really good, but I guess we have like 5, 1, 2. Okay. What forces it to have group 2? I guess if 4 is tied to like I'm trying to figure out how can I make this group 2. I guess if there was another number to the left and then this is tied to that, then in that case it would have to be is there a union find thing that I can do? Because basically not doing it. Okay, so we have okay, so let's say we start at 5 and we have 0, 1, 2, and this goes to 6, but then 6 is 3 going to 0. What does that mean? 3 going to 0 means that 6. How do I combine them in a good way? Well, that means that basically if 6 is connected to 5, then it would collapse into 2. I don't even know how to. Maybe. And just by part it always has an answer, but I guess I could type that first. Is it always connected? Can it be disconnected? Okay, well, okay, fine. get this one right. Well, okay, that's not great that it thinks this one is wrong too. Why is that? I can't even get coloring right. Okay, fine. Alright, this is why we test, I suppose. This one indexed. Why? Tell me why. Okay. Now, a lot of people have gotten it. 6 is close to 5, then we have to collapse. But how do we even choose? What if it's a 6 loop, right? If it's a loop that has 6 elements, then how do we do it? If there's a loop with 6 elements, then every loop has to be combined, right? So basically, anytime there's a loop, anything that's in that loop will be merged into 2 things. Yeah, people are really good at this one. my ranking is still pretty bad, but I'm just putting my notebook bit. So if there's a back edge, I don't know how to represent that in a good way though. And then, for example, there's a 1, 2, 4, 6 loop. So that's not true then, right? Because the 1, 2, 4, 6 loop is still 3 things. This is not a good time test to be crap on the first 3. Maybe on a normal day I would have been okay, but people are very smart. just too much graph here for me, maybe. I thought that the cycle might be resolved, but if there's a back edge, well, in this case, maybe I drew it wrong. That it could be 2. But even that, I could draw 3 here, right, Larry? So a cycle is a thing of 3. And then of course each force is just whatever each tree in the forest. So a cycle is actually 3. Is that actually true? I don't know that I could prove it, but I mean, I might as well do something. Okay. And then maybe I could get a test case out of it at least. What am I doing? So this is cycle this 3, but how do I get around looking into it? And then also there's a dangling thing where you this one's hard. Did Josh get it yet? Oh, Josh is not doing something. Wow, people are very smart though. Huh. I have so many cases, I don't even know that I can't even debug anything, even if I don't. Okay, fine. So I want to return, say, number of nodes and then maybe some kind of crazy math, right? So basically, if So then as soon as it branches off, then what? If I have something like this, then I know that it goes back, back, back. There's no contribution, right? It's part of a cycle. What if you have two cycles linked to each other? I don't even know. I don't know that this is the right way to do it then. Or like I don't know how to figure it out. This is a very bad contest just to do mistakes on. But it is what it is. What do I do by first search? Well, if I do it 204 and then 606. No. Oh. Is it that dumb? I do a breadth first search then by definition, right? This is a hard problem, but I don't know that I could prove this. Why not? Okay. But what if the last... No, oh wait, no, yeah, okay. Okay. I guess we'll just do it this way. So much penalty too. That's not quite right then, is it? So, wait, did I mess that up? Oh, because I count from 1. If n is 500, we could do 500 square. It's just that if you have disconnected forces, it's a little bit weird. I see, because if I rooted this at 1, then it would have only be 3. Okay. Okay, maybe I just do something like this. This is not a... Larry, what are you doing? This is not a tree. Only tree is you being an idiot. Idiot. Um, Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and the explanation. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.